All right, next question. We're looking at f of x is e to the minus 1 over x, and we are trying to identify essentially curve sketching. So first way you want to get this done is go ahead and just drop it in decimal so you see what you're supposed to get, right? That'll give you some insight in terms of where you are headed. So we have this function that is kind of piecewise expressed. There's a piece on the left side, a piece on the right side. And so let's see, we can kind of determine how we can use analytical means to derive some of these properties. All right. So domain E is all good everywhere. 1 over x is not. So essentially is where x is 0, right? That's the only issue. That's a problem. Okay, as far as the asymptotes, since I'm kind of tight for space, I'll look at the limit x goes to infinity of e to the minus 1 over x. We've seen this multiple times in this practice exam. Because 1 over infinity, right, infinity increases, 1 over infinity goes to 0. That's like e to the negative 0, which is 1. So that is a horizontal asymptote, y equals 1. Okay, so I hope that makes sense, right? As x goes to positive infinity. As x goes to negative infinity, we're going to have a similar situation, right? So that's our horizontal asymptote. Our vertical asymptote is where we have a finite number that we approach and then the thing blows up. Okay, so for our vertical asymptote, limit x goes to 0. Let's check it out from the left of e to the negative 1 over x. As the denominator gets smaller and smaller, then we end up approaching infinity, right? That's e to the infinity, and that's going to be e to the positive infinity. Negative over negative is positive. Okay, so we get an infinite answer. So we have a VA at x equals 0, right? There's nowhere else to check except the place where the domain has a gap, right? Of course, if we try to limit as x approaches 0 from the right, you may remember from what we saw in Desmos, this is not going to happen, right? Because if you approach 0 from the right, that's like e to the minus infinity, right? Which is equal to 0. That's not infinite, therefore that's not an asymptote. All right, so when it comes to the y-intercept, we know that means you plug in x equals 0. All right, but hold up. When we plug in x equal to 0, we know that's not in the domain. So by definition, this thing does not have any y-intercepts, even though if you look at the sketch, it looks like it does intersect the y-axis at 0, 0 at the origin right here. Okay. However, 0 is not in the domain, clearly, from the way the function looks, right? So this, again, is a piece where your calculator doesn't always have the sensitivity to really understand what's going on. Okay, so, there is no domain, so no y or x intercepts. Okay, symmetry. F of negative x is e to the negative 1 over negative x equals e to the 1 over x, which is not equal to f of negative x or f of x, so there's no symmetry. Increase, decrease, extrema, that's where we got to find the derivatives. D dx of e to the minus 1 over x is equal to, same thing, multiplied by the derivative. We saw this a little bit earlier, so that's minus x to the minus 2 times negative 1. So it's going to be this. Okay. So the critical values, we set it equal to 0, and you get either 0 or undefined. Now we know this thing is not going to be equal to 0, so undefined at x equals 0, right? So to find intervals of increasing and decreasing, we have to take a look at 0 as our demarcation point. Seems to be some confusion as far as what is to be done with this table. So let me refresh your memory. Okay, this is going to be the x values up here. This is going to be our f prime of x. And this is going to be our f of x. Okay, the x values start at negative infinity. Then we have our critical value of 0. Then we have an infinity. Okay, therefore this interval is going to be from negative infinity to 0 and from 0 to infinity. Okay. All right, so when x is negative, that's the first interval. This whole thing is going to be positive, right? And it's always going to be positive because e is positive and x squared is positive. So it's like that, increasing, increasing. So there is no local extrema. All right, now let's find the second derivative. Let's go ahead and use the quotient rule. F prime is just what we had earlier, which is x to the minus 2 e to the minus 1 over x times g, which is x squared. Okay, g prime is 2x times f is e to the minus 1 over x. Okay, so as we've reached the end of this course, I expect you to have a lot more swagger, a lot more confidence in terms of finding these derivatives without having to go through some explicit steps to it, right? So we end up with e to the minus 1 over x minus 2x e to the minus 1 over x to the fourth e to the minus 1 over x times 1 minus 2x over x fourth. Okay, as far as our critical numbers, we don't get anything from here. Here we get an x equals 1/2. Here we get an x equals 0. Alrighty, and that's going to inform what we do over here. Now we got x and f double prime, and then f. Okay, I always start at negative infinity. The next demarcation point will be 0. Then we have a 1/2. Then we have a positive infinity. This interval is from negative infinity to 0. That's 0 to 1/2. That's 1/2 to infinity. Okay, then we check the intervals. Negative infinity to 0. So looking at the denominator, that's always negative. I'm not worried about it. I'm just looking at the numerator. Looking at the numerator, that's always positive. Okay, I think I said positive down here as well. So positive, positive. Not worried about these. Only worried about this. So if x is negative, this is positive. If x is between 0 and 1/2, let's say we plug in like a quarter, that's going to be negative. And then if x is, bigger than 1/2, let's plug in a 10, that's going to be negative. Okay, I lied, this is positive. All right, yeah, because that's 2 times, all right? So therefore, we're going to end up with concave up, concave down, okay? Then we want to sketch the graph based on everything we see. Obviously, we saw it in Desmos, but the idea is we know that we are increasing, right? Having a horizontal asymptote starting at 1, steadily increasing and concave up as we approach the y-axis with a vertical asymptote. So we're going up here at 0, 0, but we have an open circle at that point. Okay, then we have up to 0.5, we are concave up. Now, when we plug in a 1/2 into our function, when we plug in a 1/2, you get e to the minus 1 over 1/2, which is e to the minus 2, about 1/9. So let's say somewhere over here. So we're concave up, coming this way. And then we switch to being concave down, approaching 1 as an asymptote. All right. Does f have an absolute max? If so, stay where it occurs in the max value. Well, given the fact that we have a vertical asymptote, I don't think so. All right, so just to repeat, here we go. And you can see the concave up over here, and it switches to concave down over here. Beautiful.